Hello everyone, this is teacher Cleophas, and today we shall discuss the properties of waves. Welcome. Our objectives are as follows. 1. By the end of this lesson you should be able to state and describe the properties of waves, and objective 2, you should be able to relate wave speed, wavelength and frequency. Make sure you subscribe to our channel, and I promise you to be giving you the best videos ever for your studies and revision on a regular basis. Our first term is amplitude, which is usually denoted by small letter a. Amplitude refers to the maximum displacement of particles from their mean position or from their starting point. Before we demonstrate amplitude on a wave, let's first learn what crests are and what troughs are. A crest is the highest point on a transverse wave. This can be shown on this wave, the maximum point, that is a crest. We can show as many points as possible. That's our second, and this is our third crest. A trough, on the other side, is the lowest point on a transverse wave. So we can show that is a trough, and this is a trough. And if this wave is continued, we can show as many troughs and as many crests as possible. Let's now represent amplitude on a wave like this wave here. Since we had said that amplitude refers to the maximum displacement of a wave from the mean position, then this can be the distance from the x-axis to the crest. That distance is what we call amplitude, or it can be the distance from the mean position to the trough, and that is amplitude. It is worth noting that the distance between a trough and a crest is usually double amplitude. Our second property is wavelength. It is usually denoted by letter lambda. What is a wavelength? Wavelength is the distance between two successive crests or troughs, or it can also be defined as the distance between two consecutive points in the same phase. So let's mark the key terms here. Consecutive points, the distance between two successive crests, or the distance between two successive troughs. So this is the distance over which the wave's shape repeats. We can show this on this wave. That distance highlighted in red is equal to 1 wavelength. It can be shown on any part of this wave. So we can also show it on the lower side, which is the distance between two successive troughs, and it can also be shown like this. So that is also a wavelength. Our third property of the waves is frequency, which is usually denoted by small letter f. This is the number of complete cycles or oscillations per unit time. For transverse waves, frequency refers to the number of crests or TRAVs per second. Whereas for longitudinal waves, this is the number of compressions or number of rarefactions per second. The unit of frequency is Hertz, which is usually represented using the symbol capital H, small letter Z. A bigger unit for frequency is kilohertz, whereby 1 kilohertz means 1000 hertz. The fourth term is velocity, which is denoted by letter V. This is also known as the speed of a wave, and it is determined by the number of waves passing a point per second and the length of the wave. The wave speed in any medium is usually constant. Velocity can be expressed as wavelength times frequency, which can be written like V equals to lambda f. For example, determine the speed of a wave whose wavelength is 20 centimeters, given that it makes 720 cycles in 1 minute. Solution. Here we know the wavelength is given already as 20 centimeters, which can be changed to SI unit, which is meters, by dividing by 100, giving us 0.2 meters. The frequency is equal to 720 divided by 60, because we are told that it makes 720 cycles in 1 minute, whereas 1 minute is 60 seconds. So 720 divided by 60 will give us 12 hertz as our frequency. Since we know that V equals to lambda f, we substitute 0.2 times 12, and this gives us 2.4 meters per second as our wave speed. The fifth property is period, which is denoted by capital T. It is also known as the time period of a wave. So, in definition, this is the time taken by a wave to complete one cycle or one oscillation. The SI unit is seconds, and the relation between the period and frequency is that T equals to 1 over F. In other words, the time period is the reciprocal of frequency, which implies that the frequency is also the reciprocal of the time period, which can be written as F equals to 1 over capital T. For example, determine the period of a wave whose frequency is 20 hertz. Solution. Since we know that T equals to 1 over F, T should be equal to 1 over 20, since F is 20. So, our answer is 0.05 seconds. Now it's your turn to try out some questions and test your understanding on what we have just learned. Question 1. Define the following quantities and state their SI units. 1. Wavelength. 2. Frequency. 3. Time period. Then question 2. Calculate the frequency of a wave whose wavelength is 0.1 meters and is traveling at a speed of 5 meters per second. Coming very soon. See you then. Thank you.